Alright, welcome to Math 8. This is Chapter 1, Lesson 1. We're looking at the key concept today of rational numbers. Again, this is from your textbook here, and it tells you here that a rational number is a number that can be written as the ratio of two integers in which the denominator is not 0. On your picture here, we can see we have our natural numbers, which are going to be your basic counting numbers from 1 up to a long way. Whole numbers means we're going to add the number 0 into that mix. When we get to integers, then we start talking about having a negative number as well as whole numbers and natural numbers. But our rational numbers are the ones that are outside or beyond those, and those tend to be fractions or decimals that tend to repeat, and even some percentages here as well. So we're looking at rational numbers today, and we're going to look at some of your practice problems from your textbook, beginning with page 11, and we're going to go through a few of these together just so you're on the right page for your homework and make sure you understand this as much as you possibly can. So it says, first of all, number 1, write each fraction or mixed number as a decimal. To do that, we're going to have to recognize that this fraction is also 2 divided by 5. So to write that out, we can take the 5 here, and we're going to put that into 2. It's 2 divided by 5, and we're going to add a decimal point here right away. I always tend to drop a few zeros in there. I don't know how far I'm going to go. I tend to write 3. And the first thing I do is I'm going to move my decimal point up because I want to have that placeholder there as well. And so I used to call it the satellite dish. So I immediately put my satellite dish on top of my house, so I'm ready to go. Does 5 go into 2? How many 5s fit inside the number 2? If these are my fingers, I have 2 fingers. How many 5 fingers can you get? 0. I can't get any more 5s out of the 2. But if I look at the next set of numbers, I have 20. And if I had 20, 5 times what number can get me to 20 or close to it? Well, I would say it's 5 times 4, because 5 times 4 is actually 20. So I'm going to subtract here, and 20 minus 20 is 0. So because I'm at 0, I can stop at that point and say that I'm all done, and the answer 2/5 can also be written as a decimal as 0.4, or what's known as 4/10. Let's look at number 2. Number 2, we have 2 and 1/8. All right, a couple ways of approaching this here. I could automatically recognize that because I have a whole number, I'm going to have a 2 point something or other as my answer, and I could just mess with the 1/8. That could work out just fine. I'm going to work that way first of all, so I'm going to do 1 divided by 8. All right. Now 8 goes into, put my satellite dish up on top, 8 goes into 1 0 times, but 8 goes into 10 1 time. 1 times 8 is 8, so I subtract. 10 minus 8 becomes 2. I'm going to bring down the 0, so now I have a 20 down here, and I'm going to ask how many 8s are inside the number 20. We're going to go with 2, because 2 times 8 is 16, and we're going to subtract again. 20 minus 16 is 4. I'm going to have to add another 0 over here. Bring down another 0, and 8 times what number gives me 40? We're going to go with a 5. And 5 times 8 is 40, so this becomes 0 left over. So now my decimal point becomes 2 point this stuff, 125. So my answer is 2.125. You might have done this a little bit longer. You could have said I have 2 and 1/8, and I might want to write that as an improper fraction. To do that, you take your denominator, and you multiply it by the whole number out front, the 2, and then whatever that answer is, you add it to the numerator to come up with your improper fraction. So 8 times 2 is 16, and 16 plus 1 is 17. So as an improper fraction, I could write this as 17 over 8. And from there, I could have then done my division problem. Oops, sorry, both are backwards there. I could have done the division problem and said that I have 8 going into 17. And if I do that, I notice that right away, 8 goes into 17 2 times, and I have 16 here with 1 and 0 there. Bring my satellite decimal point up there right away, and 8 goes into 10 1 time, and I'm back to where I was before. So this is another way of doing it if you wanted to convert your mixed fraction into an improper and then turn that into 17/8. You could do that. I just chose to recognize that that whole number will become my whole number here in my decimal term. So it depends on what your teacher wants you to do, but there's a couple ways of looking at that on that problem. For number 4, same type of idea. I have 4 over 33, which is also going to be 4 divided by 33. So I put my decimal point in place. I'm going to add a few zeros out here. I don't know how many. And I'm going to put my satellite dish on top of my house to start off my problem. 33 goes into 4 0 times, but it goes into 40 at least one time. So I have 1 times 33 is 33. 40 minus 33 is 7. But I don't have an end point here, so I'm going to bring down a 0 and keep going. 33 goes into 70. Not quite sure, but I know if I double 33, I get 66, and that's pretty close to 70. So I'm going to go ahead and double it. 2 times 33 is 66. And I'm going to subtract 70 minus 66 happens to be 4. All right, and so now I bring down the 0, and I notice I'm back to where I started. Does 33 go into 40? Sure it does. It goes in there, we already know, one time. And we have 33. We subtract that, and we're back to a 7. And so I'm going to see this continues to go on. I bring down another 0, and now I'm at 70, which I already know is going to give me a 2. So what I notice is I'm repeating 12, 12, 12. So I could write this solution as 0.12, and the repeating part now is 1, 2, is 12 hundredths. That's going to continue on forever and ever and ever, and that's how I'd write that there. Okay, let's move down to the next set of problems here. On this next part here, I'm going to kind of help set you up here a little bit. It says express the fraction of students with no siblings as a decimal. Well, our no siblings, number of siblings is none right here, is 1 over 15, or 1/15, which means we're going to take the number 1 and we're going to divide that by 15. And we're going to work that out just like we did the other problems. In doing that there, I put my decimal point up to begin with, and I do 1 divided by 15. It goes into 1 0 times, it goes into 10 0 times, and it's going to go into 100 quite a number of times actually. We're going to say it goes in there about 6 times. 6 times 5 is 30. 6 times 1 is 1 plus 3 is 90. So I'm left with 10 left over. If you notice right away, when I bring down the next number, I'm back to 100, which means I'm going to do 6 again, which gives me another 90, and it continues. So in this case, I have 0.06, and the 6 is the number that continues to repeat. And that's the fraction, or the decimal way of writing down 1/15. On part B, it says find the decimal equivalent for the fraction of students with 3 siblings. So I look here at the 3 siblings, which is 1/6, and I'm doing the same thing again. I'm going to do 1 divided by 6. And I'll put my decimal placeholders in place, put my satellite dish up on top to start with. 6 goes into 1 0 times, 6 goes into 10 1 time, so I have a 6 there, and I have a 4, and bring down my 0. 6 goes into 40, a whole 6 times there. Yep, 6 times there. Sorry, just looking at something. 6 times there. So 6 times 6 is 36, and I have a 4 that comes down, and I bring down my 40, and I have another 6 there, and this would continue on and on. So my decimal value here is 0.16, and the 6 is what repeats, not the 1, so my repeating bar goes over the 6 as such. Okay, let's look down at the bottom part of these questions here, because there are some good ones down here that you may have gone over, and maybe not, but it's a little bit tricky because we're going to be writing a decimal as a fraction or mixed number in simplest form. Okay, some of these are not too bad, but when we get some repeating ones, that's where we want to focus a little bit of time on. For number 8, first of all, I recognize that this is in the 10th place as a decimal point. That's my tenths. Whereas over here, this is in the hundredths. So because it's in the tenths, I can simply write 4 over 10. It's 4/10. Now that can be reduced by dividing both sides by 2, top and bottom. 4 divided by 2 is 2, and 10 divided by 2 is 5. But I have to make sure I don't stop there because I'm not quite done. This is a negative value, which means my fraction is also going to be negative. So I have -2/5 for that answer right there. That one's not too bad, but then when we get to number 10, we get this little different type of problem here that might be a little bit more complicated. See, with the decimal bar there, or the repeating bar, it tells me that that value is going to go on forever and ever and ever. And so what our example in the book showed us to do was, let's make n, we're going to make a value, equal to 0.22222 on and on and on forever. Okay? Now, in order to figure out a fraction for this one, what I'm going to do is I want to move the decimal over one spot at least, in this case here, so that I can do some more math with it. To move a decimal over one spot, I multiply both sides by 10. So if I do 10 times 0.222 forever and ever and ever, I end up with 10n on one side, and I end up with 10 times 0.22 moves the decimal over, I end up with 2.22222. Now I'm not done yet. If you remember at the very beginning, I said, well, let's call 0.222 n. Now I want to use that value, and I'm going to subtract an n from both sides. On this side, I'm going to subtract the letter n. On this side, I'll subtract the value of n, 0.22222, from both sides. Okay? So 10n minus 1n leaves me with 9n. And over here, 2.222 minus 0.222 leaves me with simply 2. Because this part here will go away. Now I can divide both sides by 9 to get n by itself, and my value for n is going to be, now at this point, 2/9. Well, 2/9 ends up being what my fraction value is for 2 repeating. And that's my solution there. Okay? I'm going to do some more on the back side because this is a tricky part of this lesson here, and that's in simplest form. It's not negative, so it stays positive, but my answer here is 2/9. Let's turn the page and look at a couple more examples like this. On number 11, we have the same type of problem, but now we see we have 0.45. It does say to show on a separate piece of paper because I can tell you there's not enough space right there to solve that one. I've tried. Alright, so let's begin the same process. Let's say that this is 0.4545 and it goes on forever. We're going to call that n. Now this happens to be a negative value. For my purposes, I'm going to come back to the negative later because it's not going to change how I do things. I just need to know that my answer has to be negative. So I'm not going to worry about it for right now. So if n equals 0.4545, I need to move this decimal over so that I can get rid of the repeating part. If I move it over only one space, I'm going to end up with a 4.5454. Not going to work. So I actually want to move it over 2 spaces. Because I want to move over 2 spaces, I'm going to multiply not by 10, but I'm going to multiply both sides by 100. So this becomes 100 times n and 100 times 0.4545 repeating. As a result, I end up on the left side with 100 n, and on the right side I end up with that equaling, moving over 2 spaces, 45.4545 repeating. Now I can go back and subtract the n value to end up with some whole numbers I can work with. So I'm going to subtract 1n from this side, and over here I'm going to subtract my value of n, which is 0.4545 repeating. So I have 2 subtraction problems going on. 100 minus n is equal to 99n, and over here 45 point repeating minus repeating leaves me with simply 45. As a result of that, when I look at those things there, I go, well, that's not too bad. Well, let's divide both sides by 99 to get the n by itself. Right, that makes that go away. So 99 over 99 is 1. So now I have n equal to 45 over 99. Now, as always, we want to write it in simplest form. You might not recognize this right away, but look carefully. It's pretty big. We might be able to do something with it. And in fact, if I divide both sides by 9, top and bottom, by 9, 45 divided by 9 is 5, and 99 divided by 9 is 11. So I end up with 5 over 11. But remember, back at the beginning, this was a negative value, and so my solution would actually be negative 5/11 in simplest form. Okay? Let's take a look at number 12. Number 12, I have 2.777. Alright? First thing I'm going to do is recognize that, well, whatever I do here, I know my answer is going to be 2 and some sort of fraction thing. I don't need to worry about the 2 so much. It's not a big deal. Okay, I know I'm going to have a 2 in my solution. I'm going to play with the 0.77 bit. So let's go ahead and set n equal to the repeating part, 0.77 repeating part. Now I want to do the same process I did before. I'm going to want to get rid of the repeating part, so I'm going to multiply both sides by 10. 10 times n equals 10 times 0.77 repeating. That gives me, once again, 10n equal to 7 point repeating stuff. I will subtract n, my value that I created, and subtract the repeating stuff from this side, and find out that 9n equals 7. And because 9 equals 7, I'll divide both sides by 9 again, and end up with n equal to 7/9. Okay? So we're in pretty good shape there. N equals 7/9. But remember, this is just the fraction part. I still have the whole number. So I'll plug that back into my initial 2 and 7/9. So my answer becomes 2 and 7/9. So that's what I did there. I took the whole number out and just took that out of the problem and just worked with a decimal point by itself. On number 13, this one's here simply to trick you. It wants you to think this is repeating, but do you see any repeating bar over the top of that? No, there is not. So I know that I'm going to have a 5 as my whole number answer, but I need to figure out that fraction component. This is simply 55 over, not a tenth, but over 100. And 55 over 100 can be reduced. 55 can be divided by 5, as can 100 be divided by 5. 55 divided by 5 equals 11, and 100 divided by 5 is going to be equal to 20. So we end up with 5 and 11/20 for our final solution for that problem. Again, this was just designed to trick you, to have you be running and being in a hurry to have repeating. It must be the same. Nope, it's not the same. All right, hopefully that helps you a little bit with some more examples from your homework. There are additional problems in extra practice. And if you have any more questions, just check with your teacher. Have a great day.